Right, this is the 2013 external day 1, question 2. We're expanding quadratic. Right, part B, factorising. Now 60 of course has a lot of factors. 4 times 15. And there might be others as well, but we'll see if any of those work and give me a difference of 7. Not immediately. Of course 5 times 12 is 60 and that would have a difference of 7. So it's a negative 7, so the larger one needs to be the negative. Right, part C, factorise the following expression. Now when we're asked to factorise, we always see FF. Look for a common factor first. So looking through here, there's a common factor of 2. They all have an A, and they all have a B in them, leaving me with a 3A for the first term, 2B, 2A. Right, before we rush on, I just noticed that inside that bracket I could combine the 3A with the 2A, and that would be the final factorised version. Part D, solving a quadratic equation, looking for values of n such that when I substitute them into the left hand side I'll get 0. Obviously substituting n equals 4 everywhere there's an n would give me 0 times 7, which is 0, and substituting n equals negative 3 wherever there's an n would give me a 0 times negative 7, which once again is 0. So the two options clearly 4 or negative 3. Next one, E, is a single fraction. Really helpful if you can put that one over 1 and make that one a fraction as well. We're subtracting, so we're going to need a common denominator, which means multiplying this one by 4, top and bottom by 4. We're actually multiplying by 1. So we're not changing the fraction, but it gives us a denominator of 4. 8x minus x minus 3. Now there's a real trap set in this question, and it's that negative there. And if you don't put brackets around your x minus 3, you're going to find you make a mistake on the sign, because it should be 8x take away 1x is 7x, and then minus a minus, two negatives make that plus 3 over 4. So if you tried that question, you have a look and see if you got caught in the trap. But the trap is set there with the negative sign. Don't get trapped in it. Use brackets. Now we're on to the word questions. Nick and Marnie. Nick is paid $15 an hour. He gets $15 an hour. Actually, Marnie is paid $15 an hour. Nick is paid $13 an hour. Altogether they earn a total of $166. Now Marnie worked for M hours and Nick worked for N hours. So if I was going to work out how much they got altogether, we'd need to multiply 13 times the number of hours that Nick worked. Add that to $15 times the number of hours Marnie works, and altogether it's given me a total of 166. Right, part 2. Altogether they worked a total of 12 hours. So that must mean that N plus M is going to equal 12, because N is the hours that Nick did. M hours for Marnie, so altogether it was 12 hours. So there's my two equations. We'll just write them out again. Two equations have to be correct at the same time. This sounds like simultaneous equations. We could take the second equation here and either introduce a coefficient of 13 in front of the n or 15 in front of the m. Doesn't matter which way you do it. I'm going to take that and multiply everything by 13. So 13n plus plus 13m equals, now we need 13 times 12. 12 12s are 144, plus another 12, 156. You might need to do some long multiplication on that. Now I can see that 13n plus 15m is 166, 13n plus 13m is 156. So there are 2 extra m in that first equation. First equation has 2 extra m and an extra $10 on this side. So the extra 2m in equation 1 must be the same as 10. The other way, of course, we've done it in class is to subtract. 13n minus 13n is 0, 15 minus 13, 2, 6, 6, and clearly m equals 5. So if Marnie worked 5, altogether they worked 12. So n must be 7. Now let's go back and read the question. How many more hours Nick worked than Marnie? So Nick worked 2 more hours than Marnie. Really important that you go and read the question and you write a sentence. Part G, got a cylinder and a cone. They've got the same height. So here's my cylinder. Now we want a cone with the same height. We'll call that one with a height of h. That one's got a height of h as well. The volume of the cylinder is pi r squared h. So the cylinder has a radius of little r. Volume of the cone, and it's got a radius of capital R. The volume of the cone is half the volume of the cylinder. Describe the relationship between the radius of the cone and the radius of the cylinder. So we want to compare little r with big R. Not a lot to go on, but we do have 2 formulas here. And we're told that the volume of the cone is half of the volume of the cylinder. So the volume of the cone is a third pi r squared h. Volume of the cylinder is pi r squared h. That's what we're told. Now I don't like these fractions here, so what we're going to do is we're just going to bracket both sides. It's all multiplication. I'm just going to times both sides by 6, or 6 over 1. Because 6 over 1 times 1 over 3, 3's into 6 go 2. And similarly over here, it's all multiplication. There's no plus or minus, so you just everything's multiplied together. 2's into 6 go 3. And now I've got rid of the fractions. We could try dividing both sides by a pi and an h. What you do to one side, you do to the other. Okay, it's looking a lot simpler. Now, we do want to get little r and big R. Describe the relationship, and then describe the relationship in words as well. Doesn't matter which way we go from here, whether we get big R little equals, or whether we get little r equals, as long as we try and get one of them on its own. So I'm going to persevere with big R. Let's divide both sides by 2. And now I'm going to square root both sides. What you do to one side, you do to the other. Right, and that's looking really good. Just one little step we could do to make it even more obvious. And that is, because it's multiplied in between these two, I can actually square root the r squared, rewrite it, leave that one there, but write it as little r. Only because of the times. If that was a plus or a minus, you can't just square root individual pieces under the root sign, but it's times, so I can. So now I can see that the radius of the cone is that factor times the radius of the cylinder. Radius of the cone, 3/3/2 times the radius of the cylinder.